Welcome to the video from Lecture 14, Section 4. This video will cover solenoid valves and flow valves. Solenoid valves are either electromechanical or pneumatic devices that control gas or liquid flows. When a valve is controlled with an electronic signal, the device is commonly called an electromechanical solenoid valve. One way to think about electromechanical solenoid valve is to think of it as a valve with a solenoid attached. When the control signal is a pressure, it is commonly called a pneumatic relay. Like relays, valves come in different forms. The first form we will talk about are two-way valves. Two-way valves have one inlet and one outlet. The valve has two positions, open and the flow is on, or closed and the flow through the valve is off. Some two-way valves can have intermediate positions that are proportional to the control signal. The idea is that a control signal is proportional to the flow through the valve. Like many of the other devices, one of the important characteristics is what is the normal de-energized valve position, open or closed. A normally closed valve is closed and does not allow flow through the valve in the de-energized state. A normally open valve is open and does allow flow through the valve in the de-energized state. This slide introduces three-way valves. A three-way valve has three connections. One connection is called the common connection, which is labeled as the number 1 connection in this figure. This connection allows flow at all times and is either connected to port 1 or port 2. So a three-way solenoid valve switches either port 2 or port 3 that is connected to port 1. With a three-way valve, both port 2 and port 3 have normal designations which are opposite to each other. The sketch shows a three-way valve for which port 2 is normally closed when the three-way valve is de-energized and port 3 is normally open in the de-energized state. In the energized state, port 1 is connected to port 2 and port 3 is closed. This layout is called the diverter application because port 1 has the highest pressure and flow goes from port 1 to either port 2 or port 3. The next slide will show what is called the selector application. Here is a sketch of a three-way valve for a selector application. As before, the port 1 is always connected and has flow, but in the selector case, port 1 has the lowest pressure and material flows in through either port 2 or port 3 to the common outlet port 1. The point of the diverter and selector application is that to make you aware of some of the different types of valves available. This slide shows several flow control valves. We talked about this a bit with the two-way valves when we mentioned that some have adjustable flows based on the control signal. Here are some pictures of some of the flow control valves available. With flow control valves, the flow rate through the valve is adjusted based on the value of the electrical control signal or the pneumatic control signal. Well, we could spend more time talking about each type of control, the flow control valve and their respective advantages and disadvantages. I think this is more than necessary for this course. Here is a list of some solenoid valve selection criteria that you might want to consider when selecting solenoid or flow valves. Do you want a two-way valve, three-way valve, or a flow valve? What size pipe is going to be connected to the valve? What types of materials do you want the valve to be made of? Plastic, brass, stainless steel? Does the valve need to be Teflon coated? What pressures will the valve be operating at? Note that some valves require some pressure on all lines so that the valve returns to its de-energized state when de-energized. Flow rates and flow resistance values are important too. Solenoid power requirements, duty cycle, and temperatures are things to consider as well. And if timing or speed is important, what is the valve response time? This brings to the end of the Lecture 14, Section 4 video. The next video will cover thermostats, stepping motors, etc. Please write down any questions you have and bring them in class or lab. Thank you.